Welcome learners. This is module 3 for Unit 1 Engineering Geology. In this module we will be studying weathering of rocks. My name is Sarath Kumar. I am working as an assistant professor in Department of Civil Engineering, GC Dharmapuri. So in this module, first we will be seeing what is weathering, what are the various types of weathering. In that we will be studying physical weathering and its types, and next chemical weathering and its types. Weathering. Our earth is made up of rocks. Rocks is a combination of minerals. Our earth itself is changing. That is, rocks are getting changed by various natural agents like river, groundwater, wind and sea. So weathering is the process of disintegration and decomposition of rocks by various agents is generally called weathering. So the process of disintegration and decomposition of rocks by various agents is generally called weathering. So what are the types of weathering? The first type is physical weathering. Rocks breaks into pieces through physical forces. There will be a physical force that will break the rock into two or more pieces. The broken pieces, compared to the parent rock, the size and shape will be different, but the composition of broken rock and the parent rock will be same. So in physical weathering, the composition of parent rock and the broken rocks will be same. Chemical weathering. Here the rocks break down through chemical reactions. There is no physical forces present. In chemical weathering, new minerals are formed as it breaks down. It creates holes or soft spots in rock so that the rocks break apart more easily. So main difference is, in physical weathering there is a physical force, there is a contact force present that breaks the rock into two or more pieces, whereas in chemical weathering the process is done by chemical reactions, and also the composition of parent rock and the weathered rock will be of same nature, whereas in chemical weathering new minerals are formed. Types of physical weathering. These are the basic types of physical weathering. Physical weathering is also called mechanical weathering. The basic types of physical weathering are abrasion, frost action, wetting and drying, actions of plants and animals, losses of overlying rock and soil. As you can see in the figure, the rocks are weathered. As you can see in the man in the picture, you can imagine how the rocks are disintegrated. So first type is abrasion. When the natural agents like ice, water, wind flows over a rock, it carries sediments in it. For example, if a river passes through the rock, the river has suspended materials, suspended silt particles that will collide, that will abrade the rock. And over a particular period of time, the rocks get corroded. It happens with wind also, it happens with glacier also. The grinding away of rock by rock particles carried by water, ice, wind and gravity is known as abrasion. In the first figure, abrasion is done by water. In the bottommost figure, the abrasion is done by wind, and the center figure is abrasion done by again water. The last vertical figure is abrasion done by wind. So here, when the natural agents flows around the rock, it carries sediments which causes abrasion in the rocks. Consequently, the rocks weathered and modified. Here there is a contact between sediments in natural agents and the rock. Frost action. Water takes up about 10% more space when it freezes. This expansion puts great pressure on the walls of container. Water helps in the rock edges the rock apart when it freezes. This happens where temperatures varies from below freezing point of water to above freezing point of water. Normally there are holes in the rocks, and when the rainwater or some type of water enters through the holes, and when the temperature goes below the freezing point, the water becomes ice. When the water becomes ice, its volume increases, but the pores in the rock cannot accommodate that volume. So the ice create a wedge in a rock, and consequently it breaks the rocks. So this is frost action. So the basic principle is water enters into the pores of the rocks, and once the temperature goes below the freezing point, the water becomes ice. So when the water becomes ice, its volume increases, and the volume cannot be accommodated inside the pore of a rock. So there is a physical force making a wedge action, creating the rocks broken into small. It occurs mostly in porous rocks and rocks with cracks in them. Bare mountain tops are especially subjected to ice wedging, because in bare mountain tops the gravity force will also help in breaking the rock pieces. It is dominant in mountain and polar regions. Alternate drying and wetting. Especially effective at breaking up rocks that contains clay. In clay, one of the minerals is montmorillonite. It has very high swelling nature. So when the water goes inside, the clay mineral will get swelled, and when it is dry, it gets shrinks. Upon alternate drying and wetting over a period of time, the rocks. Physical weathering. Action of plants. With plant growth, the root system will increase in volume and causes cracks in the rocks to expand. Lichens are primary soil producers, creating conditions for large plant growth. Sometimes in the pores of the rocks, a bird will drop a seed of the plant. The seed will grow into plant, and once it started grows, the root of the plant expands, and it will create a physical force inside the rock, which will make the rock break into two pieces. Lichens are algae. Sometimes it gives weak acid, sometimes it produces weak acid, which will help in weathering. We will be seeing that in the next chemical weathering, and also it creates a nice surface. It will absorb moisture and helps plants to grow inside the rocks. Next one is action of animals. Ants, earthworms, rabbits, woodchucks and other animals dig holes in the soil. These holes allows air and water to reach the bedrock, and once the water reaches the bedrock, the same actions as we have seen before, frost action, wetting and drying, this type of physical weathering will take place, and the rock will get weathered. Loss of overlaying rock and soil. Sometimes the rock layer comes out as sheets. For example, sheet jointing on a granite outcrop produces cracks in the rock, thereby exposing more of the rock surface to weathering. The process of outer layers of rocks peel off is called exfoliation. Once the outer layer of the rock comes out, the inner layer of the rocks are exposed to the same various natural agents, and the inner part also gets weathered. Once the inner part gets weathered, when it peels off, the adjoint inner part gets weathered. This process goes on till the entire rock gets disintegrated. Moving on to types of chemical weathering. When agents of weathering chemically change the composition of a rock, it is called chemical weathering. Normally, the three types of chemical reactions happening are hydrolysis, oxidation and carbonation. Hydrolysis is nothing but reaction with water. Some of the minerals are soluble in water. Oxidation. Oxidation is the process in which the moisture present in the minerals reacts with oxygen to form iron oxides. Carbonation. The water in the minerals, water in the rocks reacts with the carbon, form a weak carbonic acid that will dissolve the rocks. The first process is hydrolysis. The chemical reaction of water with other substance is called hydrolysis. Here given some of the minerals: feldspar, hornblende, agate. These are the minerals that are completely soluble in water. So rocks containing this mineral are easily disintegrated through hydrolysis process. Oxidation. The next chemical weathering process is oxidation. Oxygen combines with minerals to form oxides. Iron plus oxygen gives rust. So iron bearing metals or the iron bearing minerals are the ones most easily attacked by oxygen. Example, such type of minerals are magnetite, pyrite and dark colored ferromagnesian silicates. So whatever the minerals that contains iron particles will easily react with oxygen and forms iron oxide, thus disintegrate the rocks. The next process is carbonation. Carbon dioxide dissolves easily in water and forms a weak acid called carbonic acid. This is the same compound that is in carbonated drinks. Attacks many common minerals such as feldspar, hornblende, agate and biotite mica. The original mineral is changed into clay mineral. So when carbon dioxide in these minerals reacts with water, it forms carbonic acid and the resultant it will create a clay mineral. It has the greatest effect on calcite than any other mineral. It dissolves it completely with no clay left over. One of the main agents of chemical weathering is acid rain. As shown in the figure below, the acid gases like sulfur dioxide and nitrogen dioxide released from industries will be in the atmosphere. When the rain comes, these acidic gases will react with the rainwater and forms acid rain. This acid rain, when falls upon the rocks, causes rapid chemical weathering. So, chemical weather. It occurs mostly at the corners and edge of rock outcrops and boulders. So, whatever the surface which are easily accessible, chemical weathering reacts. These areas more exposed to chemicals. This process rounds the rock and is called spheroidal weathering. So, spheroidal weathering is a type of chemical weathering where the rocks, after undergoes chemical weathering, becomes spheroidal in shape. Such rocks are called as spheroidal boulders. In general, the two processes of weathering, mechanical and chemical, seldom occur alone. Since water vapor is present in the air everywhere, chemical weathering always occurs with physical weathering. Factors controlling weather. Based on the composition and structure of rocks, the rate of weathering varies. If the rock are soft, the rate of disintegration is faster, and also the rate of weathering greatly depends upon climatic variations. To the minor extent, the rate of weathering also depends upon nature of ground slope and floral effects. Thank you.